What if some of the most astonishing discoveries in modern science never made it past the cutting room floor? It begins not with a breakthrough, but with a silence. A hum, low and constant, vibrating through homes in the dead of night. A sound so subtle most never hear it. But for a small fraction of people across the globe, from Bristol to Taos, from Ontario to Australia, it's a presence that never leaves. A deep, persistent rumble that rattles the nerves and steals sleep. They call it simply the hum. Imagine living with a sound that no one else believes exists. You hear it, feel it, know it's there, but official channels brush it aside. Psychosomatic, they say, just your imagination. But then someone brings in equipment. The sound registers. It's measurable. It's real. And then the study vanishes. The results are shelved. The project ends abruptly. This is not just one case. It's a pattern. Across decades and continents, researchers curious enough to follow these threads find themselves facing closed doors. The hum isn't alone. In a remote Norwegian valley, lights flit silently across the sky. For over 100 years, they've danced above the treetops, witnessed by scientists and villagers alike. They shimmer, change color, split apart, and rejoin, moving with a kind of intent. Universities install cameras, radars, sensors. The data is irrefutable. The lights are real. But then, as with the hum, the research slows. Proposals are denied. Careers are questioned. Interest fades. Or rather, it's made to fade. Dive deeper into the ocean. In 1997, listening stations across the Pacific pick up something strange. A sound, impossibly loud, biological in nature, reverberates across thousands of kilometers. Theories abound. A massive sea creature? A new marine phenomenon? Then the explanation comes. Ice cracking. Never mind that the sound signature doesn't match, or that it came from far beyond any glacier. The case is closed. The bloop, they call it, is forgotten. At a glance, these stories seem unrelated. A strange sound, unexplained lights, a mysterious underwater signal. But look closer and a disturbing rhythm emerges. A moment of awe, a glimpse of something that doesn't fit, a surge of curiosity. Then silence. Part of being human is wondering what we haven't yet understood. Throughout history, our greatest advances began with anomalies, things that didn't fit the theory. But what happens when anomalies are no longer welcomed? When they're quietly erased from the conversation? This series is about 10 such phenomena, real, observed, recorded, and then ignored. Each has been documented by scientists, photographed or measured with instruments, and yet remains officially unexplained. Not because the evidence is weak, but because the implications are inconvenient. We begin with the hum, but as we move through valleys of light, through waters deep, into the heavens, and back to the ground beneath our feet, a question echoes louder than the phenomena themselves. What if the biggest mysteries aren't what we don't know, but what we've chosen not to see? This is a journey through the margins of science, through the places where data was gathered but answers were denied, through the stories of researchers who tried to understand and were told not to, through signals that arrived only to be dismissed as static. And in the end, perhaps we'll find the most unsettling question isn't whether these things happened. It's why, after all this time, they're still waiting for someone to ask again. Because the truth may not be hidden. It may simply be unacknowledged. It started with a diesel hum, not a sound you could trace or silence, but something deeper, resonant, low, unsettling. In the quiet town of Bristol, England, during the late 1960s, residents began complaining of an unshakable noise, a vibration more than a tone, as if the world itself had developed a pulse just beneath human hearing. Most people couldn't hear it at all, but those who could were tormented. Sleepless nights, nausea, the disorientation of hearing something no one else acknowledged. In time, the phenomenon gained a name: the hum. And it didn't stay in Bristol. It migrated: Taos, New Mexico; Windsor, Ontario; Bondi, Australia. Dozens of towns across the world reported eerily similar experiences. Always the same description: a low-frequency sound between 30 and 80 hertz, louder indoors, worse at night. Recorded on microphones, detected on seismographs, and yet largely dismissed. Only about 2% of people in any given area can hear it. But for those who do, the impact is profound. They move away. Their health deteriorates. Some are driven to psychological collapse. And still most officials shrug. It's the wind, it's traffic, it's nothing. But in 2012, something changed. Researchers managed to capture the hum using specialized equipment. They proved it wasn't imaginary. It was real, tangible, measurable. It came from somewhere. But where? Theories emerged, some plausible, some wild. Electromagnetic radiation interacting with the auditory system, underground seismic activity, military communication systems, pipeline vibrations. Each theory gained a following, none conclusive. The hum remained a riddle. Then came the deeper mystery: why was no one studying it? Proposals to investigate were submitted to universities. Some had private funding attached. Still, they were rejected without explanation. In one government-backed study, an acoustic team confirmed the phenomenon was real. They were prepared to locate its source. And then, the project was abruptly shut down. Data was classified, notes destroyed, team members told to stay silent. Some sufferers who reported the hum were referred to psychiatric services. Others were dismissed outright. But what couldn't be ignored was the pattern. The hum would stop the moment someone left the area, and it could be recorded with machines, unaffected by psychology or imagination. Over time, the phenomenon began to resemble something more than just a scientific oddity. It looked like a case study in institutional avoidance, a phenomenon that was real enough to measure but inconvenient enough to ignore. One researcher, after a decade of meticulous work, attempted to publish findings linking the hum to an industrial source. Before he could, officials visited him. No threats, just a quiet warning. He didn't publish. As the hum spreads to new areas, official silence remains constant. New reports surface regularly. Yet mainstream science holds its ground, a blank stare in the face of thousands of data points. And so the hum continues, vibrating just below the threshold of public conversation. It raises a question that echoes louder than the sound itself. When a phenomenon is both real and reproducible, what does it mean when science turns away? Maybe the hum isn't just a mystery of sound. Maybe it's a hum beneath the surface of something else. A subtle, persistent reminder that not every truth is welcomed, not every observation embraced. Sometimes the loudest silence is institutional. And in that silence, people keep listening. A narrow valley in central Norway, quiet and remote, seems an unlikely stage for one of the most enduring scientific anomalies of the modern age. Yet for over a century, residents of Hestdalen have looked to the sky and seen something unexplainable. Lights, glowing, shifting, intelligent-seeming lights. They aren't fleeting illusions or the product of overactive imaginations. These lights appear frequently, sometimes nightly, hovering, darting, changing color, even splitting apart and recombining with strange grace. They hang motionless for minutes or race across the valley faster than any known aircraft. White, yellow, red, morphing in intensity, shape, and speed. In the early 1980s, the sightings spiked. The valley lit up with inexplicable activity. Locals grew used to the phenomenon. Tourists came. Scientists, curious and cautious, followed. They didn't just observe, they recorded. In 1984, a small research station was built, equipped with radar, magnetometers, spectrum analyzers, and cameras. It monitored the skies day and night. The results were staggering, lights moving at over 8,000 meters per second. Sudden changes in direction, impossible under known physics. Electromagnetic pulses, and, at times, something else. The lights seemed responsive. They approached observers. They moved in tandem with vehicles. They appeared shortly after researchers arrived, as if they knew. The data was clear. It was repeated. Verified. Yet, year after year, funding for Hessdalen research dwindled. Academic journals hesitated to publish the findings. Major physics institutions showed little interest. When a comprehensive, multi-university research proposal was submitted in 2015, supported by decades of consistent data, it was rejected. No explanation was given. The lights kept coming. In 2007, one event caught everything off guard. As a sphere hovered low in the valley, electronics nearby failed. A scientist's wristwatch stopped. Car engines stalled. Moments later, the light vanished, and everything returned to normal. These weren't mere eyewitness accounts. The effects were measurable, reproducible, physical. Still, the lights remained scientifically orphaned. No mainstream institution claimed them. And so, the mystery grew quietly, luminous against the dark sky. The permanent monitoring station, established in 1998, continues to capture footage. Some of it is stunning. Orbs weaving through trees, pulses of light that change shape mid-air, radar showing solid targets where cameras show nothing but glow. What makes Hessdalen so unique isn't just the lights, it's the evidence. Most unexplained aerial phenomena rely on anecdote. Here, there are gigabytes of visual, spectral, and radar data, and yet, for reasons still unclear, the scientific community hesitates. Some researchers have paid the price. The lead scientist behind the 2015 proposal was later investigated by his university, not for fraud, but for alleged misallocation of research time. His career never recovered. What causes the lights? There are theories: ionized air, plasma fields, geological stress. Some suggest exotic explanations: unknown energy systems, atmospheric anomalies, or even intelligent control. But the truth is, no one knows. And worse, few seem to want to. Perhaps that's what makes Hessdalen so haunting. It's not just a place of light. It's a place where knowledge itself seems to hover in limbo. In the end, we're left with this: thousands of documented incidents, recorded on high-grade scientific instruments, yet largely ignored. The lights return again and again, waiting patiently in the Norwegian sky. And we're left to wonder, when the universe sends signals, do we always recognize them as messages? Or do some truths glow too brightly for us to face? Far beneath the surface of the South Pacific, in a region of cold, dark silence, something made a sound. It was 1997, and an array of underwater microphones, hydrophones, originally deployed to detect submarines during the Cold War, picked up something unexpected. An ultra-low frequency rumble so powerful it echoed across thousands of kilometers of ocean. The sound rose rapidly in pitch, then faded like a voice calling from the deep. It came to be known as the bloop. At first, it was just an anomaly, but then it was triangulated, pinpointed to a location thousands of miles from any known seismic or glacial activity. Scientists analyzed the waveform and were stunned. The profile suggested a biological origin. In other words, it sounded alive. But that couldn't be. The bloop was several times louder than the loudest known whale call. For a living creature to produce it, it would need to be larger than any animal ever recorded, something beyond known biology, something colossal. For a brief moment, the scientific world stood on the edge of a potential discovery. Could there be life in the ocean's unexplored depths, unlike anything we've imagined? Then came the silence. By 2005, the official explanation arrived quietly. The bloop had been caused by an ice quake, the cracking of Antarctic glaciers. But this didn't sit right with many of the researchers who'd heard the sound firsthand. The acoustic signature didn't match. The origin point was too far from any ice shelf, and known ice quakes had completely different sonic profiles. The disagreement never made headlines. Instead, something else happened. The original recordings were reclassified. Access to the hydrophone data was revoked. Papers that were in progress were quietly shelved. And those who questioned the icequake explanation found themselves increasingly isolated. But the bloop wasn't alone. Over the years, the hydrophone network recorded other unusual sounds: bursts, rumbles, pulses, some of which also bore signatures consistent with massive biological sources. Each time, the anomalies were flagged. Each time, they disappeared into archives that few could access. One researcher, who had worked with the hydrophone system for over a decade, began to notice a pattern. Every unexplained sound was set aside for further analysis, then never seen again. When he asked about them, he was told the data had been moved or lost. The ocean is vast, the last truly unexplored frontier on Earth. We've mapped the surface of Mars in more detail than the ocean floor. It's conceivable, even likely, that unknown creatures dwell in its depths. Creatures we've only heard, never seen. The bloop may have been the first whisper of one such life form, or it may have been something else entirely, a geological voice, a shift in the planet's bones. But the truth is, we don't know, and perhaps more troubling, we stopped asking. There's a curious pattern in these mysteries. Just when discovery seems within reach, the curtain falls. Not from lack of evidence, but from the decision not to look further. The bloop remains unexplained, a single sound that echoed across an ocean and into our imagination, only to be silenced. What else lies hidden in the deep? And who decides when curiosity goes too far? It began as a whisper in the stars. In 2007, astronomers combing through old data stumbled on something strange, a burst of radio waves so brief it barely registered, yet so powerful it rivaled the energy of the sun. Just 5 milliseconds long, a cosmic blip, a mystery. It came from far beyond our galaxy, billions of light years away. And yet the signal was so clear, so sharp, that it arrived on Earth nearly pristine. It didn't scatter. It didn't fade. It pierced the void as if aimed. They called them fast radio bursts, FRBs. And that first discovery was only the beginning. More followed, dozens, then hundreds. Each one a tight beam of radio energy, short-lived but immensely powerful. Some came only once, others repeated. The repeating bursts were the most unsettling. In 2015, one source in deep space emitted multiple bursts over several months. Same location, different intensities, irregular intervals. It was behavior no known natural phenomenon could explain. Radio telescopes confirmed it. The source was real. It persisted. It behaved in some ways like a beacon. Some signals displayed mathematical structures, patterns in the frequencies that hinted at information. A few even showed what looked like frequency modulations, intentional shaping of the signal, almost like encoding. It was subtle, easy to miss, but once seen, impossible to ignore. Then came the pushback. Papers describing these anomalies were quietly declined by major journals. Research grants dried up. Teams who had been devoted to the study of FRBs found their work defunded, redirected, or stonewalled. Some astronomers who openly speculated about artificial origins were professionally marginalized. One researcher described a particularly complex FRB in 2018. The signal contained a modulation pattern that repeated twice within a 1-second burst. 3 independent teams found it unlikely to be natural. Their findings never made it to print. In 2019, military officials visited an observatory conducting FRB studies, not to contribute data, but to ask questions. Shortly afterward, the observatory's research was suspended due to budget constraints. The grant had just been approved. Officially, fast radio bursts are now categorized as unexplained but likely natural, possibly the result of magnetars, collapsing stars, or exotic plasma events. But none of these theories can explain all the observed behaviors. The regularity, the energy, the location consistency. What if the bursts are something more? Not signals from space weather, but signals from space intelligence? What if they are messages, fragments of a conversation billions of years in the making, sent in a form only the most patient civilizations could understand? The idea remains speculative, but speculation is the soil of discovery. And yet this is not a field science seems eager to plow. Thousands of FRBs have now been cataloged. New ones are found regularly. And still, the conversation remains cautious, narrow, focused on conventional possibilities. But every signal is a question, a knock on the cosmic door. We've heard them, measured them, tracked them. And perhaps the most remarkable part isn't the signals themselves, but how little we've dared to answer. What if the universe is already speaking? And what if we've chosen not to listen? It drifted through the air like something out of a dream, spherical, glowing, alive with color. It hummed faintly, hovered near walls, and in some cases passed through them without leaving a trace. It wasn't lightning. It wasn't flame. It was something else. They called it ball lightning. For centuries, witnesses described these luminous orbs appearing during storms. Some as small as golf balls, others the size of beach balls, floating, drifting, hissing, sometimes silent, sometimes crackling. Some exploded with force, others simply blinked out of existence. For a long time, science dismissed them as folklore. But the sightings didn't stop. Pilots, meteorologists, even physicists saw them. In the 1960s, ball lightning entered scientific literature, not as fantasy, but as an unexplained, persistent anomaly. What makes ball lightning so captivating isn't just its appearance. It's what it suggests, a form of plasma behaving in ways conventional physics says it shouldn't. Stable, contained, long-lived. The kind of thing that, if understood, could unlock new frontiers in energy and propulsion. Then came the breakthrough. In 2006, a team in China managed to create something resembling ball lightning in a lab. Using high-voltage electrodes, they produced glowing spheres that hovered for seconds, just like the reports. The experiment was repeated, published. It matched field data almost perfectly. In 2012, another team captured the first-ever spectral reading of natural ball lightning. The composition matched predictions. It was real. It had structure. It was no longer just anecdote. Then, nothing. You might expect a flood of follow-up research, investment, global scientific interest. Instead, the field went quiet. The university that led the research was reportedly discouraged from pursuing further study. Funding evaporated. Publication opportunities dried up. Ball lightning became, once again, a scientific orphan. Meanwhile, declassified military documents revealed something curious. In the 1960s and 70s, governments had shown keen interest in ball lightning, not as a curiosity, but as a potential weapon or energy system. Research was funded, then classified, and then, as far as the public record shows, it vanished. Why would something so documented, so seemingly promising, be pushed to the margins? The answer may lie in discomfort. Ball lightning doesn't play by known rules. It challenges models of plasma behavior. It hints at mechanisms we can't explain, at conditions where the familiar laws bend or break. And in doing so, It threatens the boundaries of what we claim to understand. For a brief time, the light was captured, measured, validated. But the doors of inquiry were not flung open. They were quietly closed. Today, ball lightning still appears in scientific papers, but rarely in mainstream journals. It remains a footnote in physics textbooks, a curiosity, a maybe. And yet, the lights still appear, during storms, in forests, in homes, caught on video, witnessed by trained observers, floating evidence that nature still holds secrets we'd rather not examine too closely. Perhaps ball lightning isn't just a phenomenon. Perhaps it's a mirror, a shimmering reminder that our models of the world, however advanced, are still incomplete. In the quiet flicker of those orbs, a question glows. What else moves through the air, seen but not believed? And how long will we pretend not to see? It began with a hum, a flicker, and then the impossible. In a modest Canadian workshop in 1979, a man named John Hutchison was experimenting with Tesla coils and electromagnetic fields when something unexpected happened. A metal wrench lifted off the table, not wobbled or rolled, levitated. Then other objects began to move, some shattered, others twisted. Different materials fused together without heat. What followed became one of the most controversial scientific episodes of the modern era. The Hutchison effect, as it came to be known, wasn't subtle. It was dramatic. Pieces of aluminum bonded to steel. Wooden blocks exploded. A cannonball rose, hovered, and dropped. Entire objects bent and warped without being touched. It was all caught on film, multiple angles, verified by onlookers, including engineers, journalists, and even military personnel. It looked like science fiction, but it was real. At least something was. The effects violated conventional physics. Room temperature fusion between dissimilar materials is considered impossible. Levitation without an obvious force source contradicts everything we understand about mass and gravity. And yet the videos exist, the samples exist, the testimonies exist. What followed was not acceptance or curiosity. It was resistance. Hutchison's lab was raided multiple times. Equipment was confiscated, sometimes returned damaged. Universities that tried to replicate his experiments reported strange malfunctions, equipment failures, missing components, unexplained interference. One team even claimed their data was corrupted mid-experiment. The scientific community, by and large, dismissed the entire affair as a hoax. Critics pointed to the chaotic lab conditions, Hutchison's lack of formal credentials, and the inability to reproduce the effects on command. But this dismissal ignored key facts. The footage showed consistent effects from multiple angles. Materials fused in ways metallurgy could not explain, and the U.S. military had taken more than a passing interest. Classified documents later revealed visits, studies, and unexplained funding related to Hutchison's work. So which was it? A fraud so elaborate it fooled engineers and government agencies, or a discovery too disruptive to be acknowledged? The truth may lie somewhere in between. Hutchison himself admitted he couldn't always control the effect. His setup was unstable. Results were inconsistent. But the events, when they happened, were undeniable. In science, anomalies are often where breakthroughs begin. But the Hutchison effect never got that chance. Instead of rigorous investigation, it received ridicule. Instead of replication, rejection. Perhaps the most haunting part is what was lost. If even one of the reported effects was genuine, a new form of propulsion, a method of material fusion, a way to manipulate gravity, the implications would be profound. But rather than explore, we looked away. Today, the Hutchison effect lives on mostly in obscure circles, conspiracy forums, and grainy video archives. Its originator, now aging, remains a curious figure, part tinkerer, part pariah. But the question remains, what if discovery doesn't always wear a lab coat? And what happens to truth when it arrives in the wrong hands at the wrong time in the wrong place? Sometimes the impossible knocks, and we pretend not to hear. South Florida is not known for its mysteries. Beaches, yes. Storms, certainly. But nestled among the flatlands and palms is a place that defies engineering logic. A monument not to grandeur, but to silent, unexplainable achievement. It's called Coral Castle. Built single-handedly by a man named Edward Leedskalnin between 1923 and 1951, this strange structure is made of massive blocks of oolitic limestone, some weighing over 30 tons. He was 5 feet tall, weighed barely 100 pounds, and used no known heavy machinery. He worked only at night, in secrecy. No one ever saw him move a single stone. Yet there they stand. Walls of precisely balanced coral, a perfectly aligned obelisk. A 9-ton gate that once pivoted so smoothly a child could open it with one finger. Each piece was placed with a precision modern builders find difficult to explain. Leedskalnin claimed he knew the secrets of the pyramids, that he understood the laws of weight and leverage in ways others did not. Some who visited his workshop reported hearing strange sounds, mechanical humming, vibrations, but none ever witnessed the work itself. When he died, he left no blueprints, no detailed notes, just a site that should not exist by the laws of practical construction. Investigations into his methods found only basic tools, chains, pulleys, a crude tripod. Nothing capable of lifting and setting blocks of such size with the exactitude seen on the site. Engineers have studied Coral Castle. Some suggest he used sophisticated understanding of balance and counterweight. Others theorize magnetic fields or acoustic resonance. But none have recreated his methods with the same effectiveness, using only the tools Leedskalnin had. The gate is the most haunting artifact. Balanced on a central axis with perfect precision, it rotated flawlessly for decades until it stopped. When a team removed it in 1986 to repair the mechanism, it took a crane. They could not replicate the original balance. Even today, it doesn't swing the way it once did, and yet this marvel sits mostly ignored by the scientific world. Tourists walk through it. Brochures are printed. But no major university has undertaken a serious investigation. Engineering journals mention it in passing, if at all. Why? Because Coral Castle doesn't fit the narrative of technological progress. It suggests that a man with no formal education, working alone, may have tapped into principles we still don't understand. And that idea unsettles the foundations of modern expertise. Perhaps Leedskalnin didn't unlock unknown physics. Perhaps he simply mastered the known to an extreme degree, but even that deserves study, and yet the silence remains. It raises a deeper question when extraordinary evidence exists not in theory but in stone. Why is it easier to dismiss it than to ask how? In Coral Castle, the blocks do not speak, but their arrangement tells a story of quiet genius, of forgotten knowledge, of how mystery can be hidden in plain sight. And maybe, most of all, of what we overlook when the builder does not come bearing credentials, but only conviction. Fire is supposed to behave predictably. It needs fuel, oxygen, and ignition. It spreads outward. It leaves patterns. It obeys thermodynamics. But some fires don't follow the rules. For centuries, scattered reports have described something horrifying and strange. People consumed by flames without a clear source, while their surroundings remain intact. A body turned to ash in a chair left barely scorched. Limbs untouched while torsos are incinerated. They call it spontaneous human combustion. Most scientists avoid the term. It conjures images of fiction. But the cases are real, investigated by fire departments, documented in forensic reports. The victims are often found alone, partially or completely reduced to ash. Yet the nearby furniture, floors, even paper objects show little damage. In some cases, the fire's heat seems to concentrate entirely on the body, ignoring everything else. Take the case of Mary Reeser in 1951, found in her Florida home, reduced almost entirely to ash, except for her leg, still clad in a slipper. The chair she sat in was intact, walls were barely singed, and no accelerants were present. The temperature needed to cremate a human body exceeds 1,600 degrees Fahrenheit, sustained over hours. But crematoriums use industrial ovens. Her apartment didn't. Or the 1982 case of a woman who burst into flames in her kitchen. Firefighters broke down the door only feet away, saw blue flames through the window, but felt no heat. When they entered, her body was nearly gone. Curtains and wallpaper were untouched. Theories have emerged. The most common is the wick effect, where clothing acts like a candle wick and body fat provides slow-burning fuel. But recreations of this scenario have never replicated the complete incineration seen in real cases. Controlled burns don't yield the same results. They produce smoke, damage surroundings, and fail to reduce bones to ash. Some reports mention unusual light, blue or yellow flames. Some describe burns that seem to originate internally. In rare cases, victims were seen moments before combustion, behaving normally. Yet, despite its unsettling nature, the phenomenon is largely ignored by mainstream science. Proposals to study it are dismissed as unserious. Fire science programs won't touch it. Skeptics claim it's exaggerated or misunderstood, but they cannot explain the physics, or the burn patterns, or the selectivity of the fire. Medical examiners have noted calcined bone, something requiring extreme, sustained heat. Yet these events take place in ordinary homes without widespread damage. The combustion is local, intense, and controlled. But by what mechanism? Even today, new cases surface occasionally, always the same characteristics, always the same silence. The unwillingness to study spontaneous human combustion says more about us than the fires themselves. We like to believe all dangers are understood, all phenomena accounted for. But when something burns outside the boundaries of our models, we turn away. There is a cruelty in that silence, a dismissal not only of mystery, but of the victims themselves. If the laws of physics were truly broken, even briefly, shouldn't we want to know? Or is it easier to declare the fire never happened than to face the fact that it did? It lay buried beneath 300 feet of cold, dark water, hidden until a sonar sweep in 2011 revealed something that defied explanation. In the depths of the Baltic Sea, explorers scanning the ocean floor stumbled upon a massive, perfectly circular structure, roughly 200 feet in diameter. Its contours were striking: straight edges, right angles, smooth surfaces, features not typically associated with natural formations. Dubbed the Baltic Sea anomaly, it immediately raised questions. Was it geological, artificial, something in between? Multiple expeditions followed. Divers descended with cameras and instruments. They reported strange experiences: electronic equipment malfunctioning near the site, satellite phones cutting out, compasses spinning. As they moved away, systems resumed normal function. Closer inspection revealed more unsettling details. The structure resembled a giant disk with stair-like ridges and an entrance-like depression. A trail extended behind it for over 1,000 feet, like skid marks across the ocean floor, as if the object had come to rest after moving. Samples were collected and sent for analysis. The results deepened the mystery. Some rocks showed evidence of high heat, above 1,000 degrees Celsius, despite being at the bottom of a freezing sea. Trace metals were present that didn't belong. Isotope ratios made carbon dating unreliable. Then the barriers appeared. Funding evaporated. Permits were denied or delayed. Maritime authorities declared sections of the site off-limits, citing environmental concerns. Universities declined involvement. Private investors backed out after receiving undisclosed advice. Mainstream geologists declared it a glacial formation, though none could explain the angles, the symmetry, or the electromagnetic anomalies. Critics dismissed it as pareidolia, seeing patterns where none exist. But the data remained: photographs, dive logs, interference reports. The original Discovery team tried to continue research, but found themselves blocked at every turn. Media coverage grew sparse. Scientific journals showed no interest. So the anomaly sits, unexcavated, unexplained. To be clear, no one is claiming it's a spaceship or an ancient ruin. But its features do not align with any known natural process, and that, by itself, should be enough to warrant study. Yet the deeper the questions go, the harder it becomes to get answers. What causes the interference? Why the precise geometry? How did the object end up there, trailing a path across the seabed? If it is natural, why the silence around its investigation? Science often prides itself on debunking mystery with rigor, but in this case, it has chosen absence instead. The easiest way to explain away a mystery is to never look too closely. The Baltic Sea anomaly is not just a strange formation. It's a reflection of a larger pattern, where curiosity is stifled not by lack of evidence, but by lack of permission. Some say we're not ready for the answers, but the more troubling possibility is this: what if someone's already decided we won't be allowed to ask? On a warm night in 1977, the Big Ear radio telescope at Ohio State University was quietly scanning the skies. Its job: to listen. Not for stars or planets, but for signals, tiny whispers from the cosmos, possibly from intelligent life. At 11:16 p.m., something arrived. A narrowband radio signal at 1420 Tierschutz, the hydrogen line, the frequency scientists believed most likely for interstellar communication, blazed across the receiver. It was strong, clean, and lasted 72 seconds, exactly the amount of time the telescope would be expected to track a celestial source. It was everything a deliberate transmission should be. Astronomer Jerry Amon, reviewing the printout later, circled the signal's values and wrote one word in the margin: wow. That single annotation gave the event its name, the wow signal. And for nearly 5 decades, it has remained one of the most compelling pieces of evidence that we might not be alone. Attempts to find it again were immediate. The telescope scanned the same area of the sky. Nothing. Other observatories joined the search. Silence. It never repeated. It never explained itself. What made the wow signal so unusual wasn't just the frequency or strength, it was its perfection. It matched exactly what we predicted an artificial extraterrestrial transmission might look like. Not noise, not random, structured, focused. Skeptics offered natural explanations: satellites, reflections, comets. But each fell short. Comets don't emit narrowband signals at 1420 pg/ms. Satellites don't hover for 72 seconds in a fixed field. Reflections fade in and out. This didn't. By the early 2000s, interest had cooled. The signal was reclassified in the minds of many as an unsolved curiosity. Interesting, but not urgent. Then in 2017, a paper proposed a comet as the source. Media outlets declared the mystery solved. But radio astronomers pushed back. The comet theory lacked observational support. Its emissions didn't match. Its position didn't align. The theory, like so many before it, faded quietly. What never faded was the question: if it wasn't natural, and it wasn't human, what was it? Perhaps more puzzling than the signal itself is how little has been done to investigate it since. The exact coordinates haven't been systematically monitored. No major campaigns have been funded to watch that patch of sky. The telescope that recorded the signal was dismantled in 1998. If the wow signal was a deliberate transmission, if something, somewhere, pointed a beam at Earth and said, "Here we are," we never replied. We never even listened again properly. In an age of accelerating discovery, that silence is profound. It reflects a deeper hesitation. The fear not just of what we might find, but of what it might mean. Are we alone? Was that 72-second burst a greeting? A flare across a cosmic ocean? We may never know. Not because the answer is lost, but because we stop looking. Sometimes the most human reaction to the extraordinary is to turn our eyes away. And in doing so, we might miss the one signal that wasn't just meant to be heard, but answered. At first glance, these stories seem like outliers, rare events floating at the edges of science. A hum, a light, a signal, a flame. Each an oddity, perhaps, but together they form a pattern, not of the phenomena themselves, but of what happens to them. Discovery, curiosity, documentation, and then denial. Each of the 10 unexplained phenomena we've examined was real, measured, observed. Some were captured on film, others on radar, some heard by thousands or detected by machines designed to track the subtle tremors of the Earth or the deep pulses of the universe. And each one, without fail, reached a point where further inquiry stopped. The question is, why? There's an image we carry of science, an open hand, reaching for truth no matter how strange. But the reality is more fragile. Science is a human institution, and like all institutions, it has boundaries. Politics, funding, reputation, fear. When a discovery threatens the model, when it hints at forces we don't understand or methods we didn't invent, it becomes inconvenient. Easier to label it a hoax, or a misunderstanding, or to simply ignore it. Some of these events challenged physics. Others, our assumptions about the natural world. Some hinted at technologies not yet known or life not yet found, but none were embraced. Not because they lacked data, but because they lacked acceptance. Proposals were denied, data classified, careers derailed. Public curiosity met with silence, again and again. This isn't just about mystery, it's about what we choose to know and what we choose to avoid. Imagine if science had taken a different approach. If the hum had been mapped and traced. If Hessdalen's lights had been studied as a legitimate atmospheric or technological phenomenon. If the bloop had launched a new era of oceanic exploration. If we had turned every telescope toward the source of the wow signal. How much would we now understand that we don't? How many revolutions of thought were left on the shelf? The suppression isn't always overt. Sometimes it's quiet. A proposal that gets lost in review. A journal that declines a paper with no reason. A graduate student advised to choose something more practical. These small acts, multiplied, form a kind of invisible wall. A signal blocked not by jamming, but by apathy. And yet the mysteries remain. The hum continues in cities and towns. Lights still dance in northern skies. Signals still echo across space. The ocean still hides its secrets. So maybe the real question isn't what these phenomena are. It's this: why, when reality offers us the extraordinary, do we so often refuse to look? Perhaps the edge of knowledge is not a place of triumph, but of hesitation. And in that pause, we may be losing more than we know. It's easy to think the frontier of knowledge is a line we keep crossing, that with each passing year our understanding grows, our tools sharpen, and our willingness to ask hard questions deepens. But what if the real frontier is not out there, but in here, within our institutions, our assumptions, our collective willingness to see what doesn't fit? Consider the fate of those who tried. The acoustic engineer who recorded the hum and was told to destroy his data. The astronomer who plotted fast radio bursts and was quietly removed from his research post. The physicist who captured ball lightning spectra and found no one willing to fund his next project. The researcher whose telescope caught the clearest signal from space, only to see the instrument dismantled, the data archived, the story closed. These are not tales of fiction. They are documented, traceable, public, but avoided. Their common thread is not fabrication, but friction. Each discovery created too much of it, with prevailing theory, with funding boards, with the idea that we already understand what matters. And yet the public remains curious. These stories persist not just in alternative circles, but in the minds of millions who sense there's more beneath the surface. More to hear, to see, to ask. Mystery, after all, isn't a failure of science. It's its birthplace. To observe something new, especially something that resists explanation, isn't an embarrassment. It's an invitation, a signal that the world is richer than we thought. But when the cost of asking is ridicule, career risk, or bureaucratic inertia, that invitation goes unanswered. And so the mystery waits. Not because it cannot be solved, but because no one is willing to speak its name. Imagine a world where these anomalies were pursued with the same vigor as dark matter, fusion energy, or Mars colonization. Where interdisciplinary teams gathered not just to dismiss, but to understand. Where an unexplained event wasn't a career liability, but a starting point. How many breakthroughs might begin with a flicker of light in the Norwegian sky? A burst from deep space? A sphere of fire floating across a room? The truth is, we don't know, because we haven't tried. At least not as much as we could. Not with the seriousness we give to the comfortable unknowns, the ones that don't threaten to redraw the maps. So the question becomes, what kind of science do we want? One that protects what it knows, or one that is brave enough to learn what it doesn't? The answers lie not in the stars, or the sea, or in stone, but in our willingness to remain curious. Because if we lose that, if we choose only to know what is safe to know, then we may find the edge of science is not a boundary of the unknown, but a wall we built ourselves. In the end, it was never just about the hum, the lights, the signals, or the flames. It was about us, our choices, our boundaries. The way we react when faced with the unknown. Science, at its best, is a lens for wonder, a way to turn curiosity into clarity. But what happens when wonder threatens structure? When the questions grow too big or too strange or too soon? We've seen it again and again, a pattern of discovery followed by discomfort, followed by disappearance, promising research quietly shut down. Anomalies explained away without investigation. Brilliant minds nudged back into safe terrain. And yet the mysteries persist. A low hum that follows people across continents. Lights that move with intent above a Norwegian valley. A sound from the ocean that shakes our understanding of what lies beneath. Messages from the stars that flicker once and vanish. Fires that burn where they shouldn't. A castle of stone raised by one man, using tools no one can explain. Each, on its own, might be an outlier. Together, they suggest something deeper, that the world is still wild, still capable of defying what we believe we know, still willing to whisper secrets to anyone patient enough to listen. But the real mystery may be this: why do we so often choose not to hear? The mechanisms of suppression are not always sinister. Often they're quiet, bureaucratic, cultural, a shrug instead of a confrontation, a laugh instead of a question. And yet, behind every suppressed study or dismissed anomaly is a moment of possibility, a chance to expand the map of human understanding. This series was never about proving the paranormal or advancing conspiracy. It was about looking squarely at what has already been recorded, measured, observed, and asking why so little has followed. Because the greatest danger to knowledge is not ignorance. It's the illusion that we already know enough. The stories told here are not the final word. They are invitations. To ask more, to demand better, to reopen closed files, to listen again to the sounds, lights, signals, and silences that still wait in the margins. And maybe to remember that mystery is not our enemy. It is the birthplace of everything we've ever learned. So ask the question again, not because you expect an answer, but because sometimes the act of asking is what keeps the light on in the dark.